All right, we're working on Chapter 6, the Inquiry Lab, Distributive Property, and that starts on page 481. And this is what the page is going to look like. So the first thing that we talk about is how can you use models to evaluate and compare expressions. So that's the whole point of this one, is that we're going to look at using models to evaluate and compare expressions. So it says 3 friends are going to a concert at the fair, and they will each pay for admission to the fair, which is $6. And admission to the concert, which is $22. What is the total that the 3 friends will spend? Hold on just a second. The first step tells us to write an expression to represent the amount spent in dollars. So immediately I know that I'm going to write 2 different expressions because they both make sense to me. One of them is 3 times, because it's 3 friends, and they're each going to spend $6 plus $22. So that's one way to look at it, saying, okay, 3 people are spending $6 plus $22. Let's figure out how much they spent. But the other way of doing it is to say, okay, well, 3 of them are buying, we need to buy 3 admissions to the fair, plus we need to buy 3 admissions to the concert, and then when we add it together, that's what the total cost will be. So that's one way to look at it. So method 1 wants us to use the model, and it says that we're going to add the lengths, then multiply. So the lengths are my 6 and my 22, and then we're going to be multiplying that times 3 for each friend. So this model bar, represents how much is for one person, and then we're going to multiply that times 3. All right, so we can add up our 6 and our 22 to find 28, and we're going to multiply that times 3. Now the other one shows us that we're going to keep them separate, and we're going to do just the 3 times the 6, which is 18, plus the 3 times the 22, which is our 66. Now I want you to go ahead and fill in how much it would be if you do it the first method and how much it will be if you do it the second method, and when you come back we'll go over the answers. Alright, you should have gotten 84 for both of those answers. When you do 28 times 3 you get 84, and when you do 18 plus 66 you'll also get 84. So both expressions are equal to 84. They are equivalent. So 3 times 6 plus 22 is the same as 3 times 6 plus 3 times 22. So these are equivalent. You can use either one of these. You can use the 3 times 6 plus 22, or you can use the 3 times 6 plus 3 times 22. They mean the exact same thing. It's just piecing them apart. Alright, so we're going to go over example 1 together, and then I'll have you do 2 and 3 on your own. It says, draw area models to show the pairs of expressions are equivalent. So the first thing they give us is 6 times, and in parentheses, 4 plus 6, and then they give us 2 times 4 plus 2 times 6. So the first thing that we're going to do is we're going to go ahead and put together the first one where it's together, and it's 6 times 4 plus 6, and then the next one we'll do the 2 times 4 and plus the 2 times 6. So this first one, we're going to add up our 4 plus 6, which is 10, and then we're going to multiply 2 times 10, which is 20. We're going to fill in our little model here, and we see that we've got 2, because that's how many sets we have, and then 4 and 6 are our bar. So for the next one, we've got 2 times 4, which is 8, plus 2 times 6, which is 12. We add those two together and we get 20. When we're showing the model, we show that we're doing 2 times 4 and we're doing 2 times 6. And so they do end up coming out to be the same exact answer. Both of them are 20, so they are equivalent. So please do 2 and 3. When you come back, we'll go over the answers. Pause video. Alright, so the answer for number 2 is that if I combine my 3 plus 2 first and get 5, and then do 4 times 5, I get 20. If I have separated them and I do 4 times 3 plus 4 times 2, I'm going to have 12 plus 8, which is also 20. And when I show my models, I show that I can combine them and make it 5, or I can keep them separate and then put them together, and I'm going to come out with the same answer. Alright, for number 3, if we did the first method, we would do 20 plus 3, which is 23, and then 23 times 6, which is 138. If we use the second method, we would come up with 120 plus 18 and get 138. Again, they're equivalent. If you think back to when we were working with mental math a little bit, and we were talking about how we can separate things to make them easier for mental math, we would separate 23 into 20 and 3, and we would do 6 times 20 and get 120, which is easy mental math, and then 6 times 3 is 18, and then putting together 120 and 18 are fairly easy to get to 138. So sometimes separating them like the second method is the way that we can find easier answers. Alright, now example number 4 I'm going to do together with you. It says use algebra tiles to tell whether the pairs of expressions are equivalent. And so I'm going to use my bar for my x's and a dot for my ones values. Okay? And so the first one I have that I'm going to have 3 sets of x and 1, x and 1, x and 1. And so all together I have 3 x tiles and I have 3 integer tiles. Okay, my ones values. Now when I do the other one, I have 3 x's plus 3 ones, so I've got 3 x's and 3 ones, so 3 x tiles and 3 integer tiles. They're the same. I end up ultimately having the same exact thing. So I'd like for you to do number 5 the same way that I just showed you with number 4. If you need to rewind and watch it again, please do so, but pause the video now so that you can complete 5 on your own. When you come back, I'll have the answer. Alright, and here are my answers. I separated this set out so that I had 3 x's, 2 ones, and 3 x's and 2 ones 2 times. And so all together I have 6 x's and 4 ones. Over here it gave me 6x plus 4, so I put my 6 x's here, my 4 ones here, and I have 6 x tiles and 4 integer tiles. Alright, so it says to complete the table, use a model if you'd like to. The first one is done for you. And so it takes 4 times, and in parentheses 4 plus 1, and it separates it by doing 2 times 4 plus 2 times 1. So you're going to do that for 6 through 12. I'll do 6 along with you. So 7 times 8 plus 4. We've just talked about this, and we've decided that we can separate it and make it 7 times 8 plus 7 times 4. And then when we evaluate that, we know it's going to be 56 plus 28. And then we put those two together, and we get 83. Or no, sorry. 6 plus 8 is 14. Carry the 1. 84 is correct. Sorry. Alright, so now you do 7 through 12 on your own, and we'll come back and check your answers. Pause the video now. Alright, now check your answers with mine. In the end, for number 7, I have 108. Number 8, I have 40. Number 9, I have 60. Number 10, I have 63. 11, 60. And 12, 186. If you have any of those different, please go ahead and pause the video now so you can check what you did incorrectly. Maybe I did something wrong. It seems far-fetched, but you never know. Alright guys, so pause the video if you need to look it over more closely if you got any of those wrong. Alright. And number 3 says a friend decides that 4 times x plus 3 and 4x plus 3 is the same. They're saying that they equal each other. 4 times x plus 3 is the same as 4x plus 3. Use the algebra tiles to the right and explain to your friend that 4x plus 3, or sorry, 4 times x plus 3 is equal to 4x plus 12. So here we have the 1x plus 3, 4 times. Okay? And then over here, we can write the other side of it where here's 4x and here's 3 1s, which is what they originally said were equal. Well, if you show your friend that you've got 1, 2, 3, 4 x's and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 1s, that's a lot different than 4 x's over here plus the 3 that they said that you're going to have. It needs to be 12 because when we multiplied 4 times x, we also had to multiply 4 times 3. That was the whole idea that we were going with originally, that we would multiply 4 times x plus 4 times 3. So it wouldn't be just 3, it would be 4 times 3, which is 12. All right, number 14 says write a real-world problem that could be represented by the expression 3 times 23, and then explain how you could solve the problem mentally, which I talked about earlier. So if you need to rewind back to that expression, or that explanation that I told you about, maybe you can get the answer for this. So go ahead and come up with whatever you want to come up with, and I'll see it in class tomorrow. Number 15, how can you use models to evaluate and compare expressions? Well, hopefully you can see now that the models, when we have a full bar, and we know it's 2 times, and here's 2, and here's 4, we can also take that same bar, and if you know anything about your area formulas, this is still 2 units tall, so this is 2 times 2, and this is 2 times 4, and then you would add them both together to find the area of both of them together. And that's basically how these models are being used, like talking about area. Find the area of this one and the area of this one, and then put them together to find the area of the whole thing. You know that the height is going to be 2 over here, just like it is on this side. Alright guys, that's the end for our Inquiry Lab Distributive Property. I'll see you in school.